Okay, in today's mini lecture, I'd like to go over some of the material that we covered in our notes yesterday. First of all, I'd like to talk about what is a solution. Solution is nothing more than when you put a solute into a solvent and it dissolves. Now, what exactly does that mean? Well, the way I like to think about it is that everything is composed of tiny particles, and these tiny particles are in constant motion. They're moving back and forth. Well, if you notice when they come apart, there's a little space right here. That is called the interstitial space. And what can happen is when something dissolves, it gets in between those little spaces. Now, that's the big overlying theory, but also you have to have what is called likes dissolve likes. So you have polar compounds that dissolve polar compounds. Let me show you what I'm talking about. If I look at a water molecule, it's going to have the bent a lot hydrogens down here, and it has two lone pairs of electrons up here. So it makes it very, very polar. Negative on this side, positive on this side. So in theory, likes dissolve likes if I have a salt, NaCl. It's not just one NaCl. If you have a piece of salt, a grain of salt, you can see it, that's millions and billions and trillions of molecules. And they are going to form those crystals like this. And you can see that my NAs and my Cl's are beside of each other because we know that an Na ion is positive and a Cl is negative. So we got positive, negative, but you also got negative, positive, positive, all the way down, and it'd be three-dimensional out like this. Well, how does the salt actually dissolve in the water? That process is called solvation, not salvation, solvation. So what is solvation? Well, basically what happens is, you see how this chlorine right here has a small little negative charge? Well, the water molecule would come over here and it would align itself so that the positive end of the water molecule is beside the negative chlorine ion. That attraction is stronger than this attraction, so it breaks off. And when it breaks off, it'll come over here and you'll get a chloride. Well, then what's going to happen is another water molecule will go around it, and another water molecule. Now, do you see how the chlorine now is wrapped in water molecules? That's the space that I was telling you about. So that is called solvation, where the likes dissolve likes. Water will line itself up with the positive and negative ends. Now, whenever you start to dissolve this, I mentioned earlier about a solute and a solvent. Well, solute is what's being dissolved. Solvent is what's doing the dissolving. So I always kind of get confused. I always know that one of them is, but the other one is the other. It's kind of the opposites, but I always get them confused. So what happened was, this was way back when I took chemistry. My high school chemistry teacher said, think of it like this. If you have a beaker, and your beaker has water in it, okay? And I place salt into the water. Now, when you do that, which one is going to be dissolved and which one's going to do the dissolving? Well, of course, the water's doing the dissolving, the salt is being dissolved. So what does that mean? One of them is the solute, one of them is the solvent. So what I do is, and like I said, this is just something to help you remember. He said, write those two words out, solute and solvent. Now, if you look at this, the first here, O-O-L-L, first letter that's different is a U and a V. So if you do the alphabet, A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, the U is in front of the V. So you say, well, what exactly are you trying to get me to see? Well, what if I was to do it like this? And I was to use this example, talking about salt going into the water. Well, what's being dissolved, my salt, is the solute. What's doing the dissolving, that would be, in this case, the water, is the solvent. Guys, I don't care how you remember that. That really doesn't matter as long as you can remember that. All right, so we've covered a couple of things. We did number one, what is the solvation process? That's the dissolving. Also, we talked about the parts, which is a solute and a solvent. The last thing that I want to talk about is the types of solutions. We have a saturated and unsaturated and a supersaturated. So let me just start by giving you an analogy. I have a sponge and I have a dropper from water, and I put water in my dropper and I put a drop on the sponge. When water hits the sponge just soaks it right up. Another one soaks it right up, soaks it right up. I can put more and more and more and more and more and more on there because the sponge is not full. That says that it is unsaturated. It's not full. Now, eventually, if I did this over and over and over, I would put one drop on, blink, and one drop would drop out. One drop on, one drop out. That means it will hold no more. It is 100% fully saturated. So unsaturated means that it's not full, can hold more. Saturated means that it is full, cannot hold anymore. So the last one is a supersaturated. Now, you have to create supersaturated solutions. So what the easiest way to do it is to take and put the salt or the solute, whatever you're dissolving, into the water. Keep putting it in there, keep putting it in there, and finally you'll see that a little bit of it will settle to the bottom. That means I now have a saturated solution. The next thing I want to do is I want to heat this saturated solution. So number one, make a saturated solution. Number two, heat that solution, add more solute, and it'll dissolve more. And then number three, let it cool back down. So remember I was telling you about the matter consists of tiny particles, and these tiny particles are in constant motion. If I heat those up, the space between them gets bigger. So I can put more in it and dissolve it. Then as it goes back into room temperature, it just wraps around it and it keeps it in the solution. So what does supersaturated mean? Well, means that you have more of your solute than you would normally have at that temperature. The only way you can get a supersaturated solution is by creating it. If I just keep dumping and dumping and dumping into here and I don't ever heat it back up, it just settles to the bottom. So those are our three types of solutions. Unsaturated means it can hold more. Saturated means it's full. And supersaturated means it's overstuffed. So I hope that this kind of clears up a little bit from our notes yesterday and makes it a little bit easier for you to understand solutions.